Here's number 16, Thermochem review. This is figuring out how much heat, how much thermal energy is required to raise the temperature of 100 grams of solid mercury. So we're starting with 100 grams of solid mercury, metal. Going to heat it from negative 39 degrees Celsius to liquid mercury at 175. So we're going from negative 39 to 125, but it's going to change state in there too. So remember, as things are changing state, their temperature stays the same. You're still putting heat in. As water's boiling, you're still putting heat in, but the temperature's staying a constant. So notice the melting point of mercury is negative 39. So the first thing that's going to happen is this mercury is going to melt. So first thing is the mercury will melt. And that means the temperature will not change. So you're still putting heat in, making it melt. Once it melts, the temperature will then raise from negative 39 to 175. So this will be a two-step process. So if you look on here, the heat of fusion of mercury is 2.33 kilojoules per mole. In other words, to make a mole of mercury melt, you got to put in 2.33 kilojoules. Again, that's per mole. Now, we don't know how many moles we have. We have 100 grams of it, so which is about basically half a mole. Okay, so 100 grams Hg, it's 200.6. So basically per mole of mercury. So get into moles and then times every mole requires 2.33 kilojoules to melt, which is about 1.16 kilojoules. So we got to put in 1.16 kilojoules just to make this mercury melt, make it turn into liquid. Okay, and then the temperature is going to go up. So right now you're still at negative 39 degrees, but you're now a liquid. Now liquid. And we're putting that in. That's a positive value. Okay, so that's one value we're going to need. We're putting that in to make it melt. Now we're going to figure out how much heat went in to make the temperature go up from negative 39 to 175. Now we're going to do Q equals mc delta T. So the increase in temp would be Q equals our mass, which is 100 grams. Oh wait, we have a molar heat capacity, 27.9 joules per mole per degree Celsius. So if it was in joules per gram, I'd want to put in grams. We need to put in moles. Pay attention to those labels, joules per mole. So again, this is about half a mole. 100 grams is about half a mole. So 0.5 moles, 27.9 joules, it's in joules, per mole per degree Celsius. And our change in temperature from negative 39 to 175 is going to be 214 degrees Celsius. So multiply those, our answer will be in joules because that is in joules. And again, that's the heat you're putting in to make the temperature go up from negative 39 to 175, to go up 214 degrees. That is 2974 joules, or 2.97 kilojoules. So our overall heat we had to put in would have been 1.16 kilojoules to make it melt, 2.97 kilojoules to make the temperature go up, total of 4.13 kilojoules. If you add those two together, 4.13 kilojoules added in total. That's it.